Hi everybody, good afternoon. I'm doing this room that was released yesterday, Windows Threat Detection 3. So this is the third one, so we have 1, 2 and 3. Learn how threat actor manage to maintain access to the breach Windows host. This one is more like persistence, hacker create services or create shuttle services or add the auto start program to registry keys and things like that. So basically, that's the room. I think the final. I'm not sure. Maybe the next one, maybe 4 is X Federation or something. So this one is only subscriber. You can read from the screen and make text a little bit bigger. So what if attacker aren't satisfied with just breaching the host, but aim to stay, establish control, and use the system as a starting point for future operations? This will complete your Windows Detection 1 to as a status. So of course the learning objective is remind the concept of command and control C2. Learn why and how threat actors maintain control of the victims. Use Windows event, mainly we use Windows Sysmon and Windows log, the normal one. See how learn technique. Okay, this room 1 and 2. It's better if you want to follow the story. The lab, I'm using X3. When I use Windows, usually I access this one. Copy and paste on all of that. So task 2, they give us the tasks that were for this room. Now, if you go to the first one, task number 2, enter the command and control. The last one was related to USB. If you remember the Windows room number 2, the number 2 one was the story about USB. And the phishing attachment can infect the machine, but how do they do it exactly? How do threat actors send the command and keep control of the victim? In the last room, remember, start with the phishing email and then phishing email install malware, and that's how the command and control center start. Now they have a option without a C2. In some cases, C2 is not needed at all. For example, Theta can type the command directly using RDP session. So the previous one we've been able to get to use the RDP. So the attacker can use RDP and access the machine. Since the method become unavailable as soon as the IP is closed or secured, if after passwords are changed or things like that, most attackers choose to still set up C2 immediately after breach. So now this, for example, we have an attack, for example, attack breach the server via RDP, attack use RDP as a normal user, do whatever you do, for example, property, go to guest, change the add, for example, a user to administration group or something, for example, and then attackers see the result in the GUI. So this is an RDP session. Now, the simplest C2 for other initial access method, threat actor can't simply use RDP every time they need to run a command. So they need some process that connect back to the attacker and wait for their command 24/7. In the simplest case, the phishing attachment will be that process and establish a command and control channel like Cobalt size C2 screenshot below. We have this one. So basically, attacker send a phishing email, victim open it and connect to the C2, a C2 and the connection. These are room, I think, of TryHackMe, if I'm not mistaken about this. These links here, guys, if you want to learn. This is AP229 phishing campaign. Okay, now we have a task. They said to us to go to task 2. They give us a sysmon event. Let's go to sys2. We can see an urgent.zip. The storyline, of course, here he said which special archive did this user download, where did the attacker hide the C2, and what domain the command. So basically we're following the story. Let's do a quick reminder regarding sysmon. So the most, for example, we know event ID 1, that's how you follow the story. So a process starts of user open Chrome or Internet Edge or something. So this is important. This network connection too. The next one which is important is 11, because if user download, it means file was created. And next one is also 13, register event set value if something like that. So this 13 and 14 are connected. Rename, where is that process access row? Now this one is more other stuff, but just a reminder, we're more interested. So they give us a small, no, it's not this one. This, when you open it for some reason, it goes straight to this sysmon. It's not this sysmon with let's go out of this. Is this sysmon saved log? So we open this log, the sysmon one. The good thing is they didn't give us too much files. So if I follow the user, we start first with process 1. The user starts something. So now you can see there's a Chrome application. Now we have we're looking for 11. Look, if it's not too many, if there was too many things, so of course you go to filter current log and put your the IDs you're looking for. In our case it's small, so we can just scroll in it. So we know 1 is the process Chrome, then we have 11. This is part of the Chrome things. Is download is something. The 15, you know the 15 because sysmon 15. Where is that 15 now? File create stream hash. This event log when a normal file stream is created and is generate event that log the hash of the content of the file to which the stream is assigned. Like in this case, we have a zip folder and you have zone identifier. We can see these things. The 15 one, because I remember there's a question about the zone identifier. This is the hash they're talking about. You can see it's downloading a file called urgent. Where is that zone things? Image creation process 15. Target file name, we know it, that's a zone, is in download folder. The content zone transfer zone ID 3. I forgot this zone story. Yeah, that's one, the zip. When you find the zip, you can check it. I forgot what that command that give you where it was downloaded from. There's a room in TryHackMe talking about the zone story. You can see Chrome is, oh no, refer URL 10 14 40. That's why it's downloaded from zone ID 3. And then after that, we know it's download. So next one is the process. That's still we're switching to Edge now. Now we have, now we know the download happened. Let me see if it's in this room or the download folder. No, it's not in this room machine. Okay. We are admin. Huh? Okay, so we know the file is urgent. This is what the file was created. It was nzip. It's still downloading it. Now we have a PowerShell. Here it was it was opened. So it was after clicking it. So let's go backward. Well, the folder was created, so it means it was clicked into unzip it. Where is that file when it? No, not you. Now I'm getting confused with these numbers. 11. Where is the 11.zip? Is a streaming PowerShell network connection. And that's the DNS query. No, where is the? This is Chrome. That's the urgent file that is downloading. Control C. I can answer this question quickly. No. Oh, the file was downloaded. Oh, it's only asking for the name. So the name is urgent.zip. Control C. Why did it copy the wrong? agent.zip, and they tell us where did the attacker hide the C2 malware file. So basically after the user unzip it, so let's follow if we can get the next file create. No, this is process mean this some, oh no, after you open it, uh, the PowerShell command is downloading that update.exe, and look when it's through it. It's through it to environment variable update.exe. This is it mean that the user, because this it mean the user because it's an administrator, so it's we can maybe we can see it translated, not you. Yeah, now you can see translate that variable translate now. So that variable environment it mean is user administrator updater. That's just like Linux when you say the variable. So you can see number 11, so is the same thing. So you can go there, and then if I follow the network, because now it was installed, so if it run it network connection, I'm not sure it's this one, but we can see it in the query for DNS. It's querying this one, the road, so you know it's a connection. Of course you can ask yourself, is it really that one or something else? Let's verify. Now you can who's making the call? Process ID 434, the queries, where is the parent? Query status process ID. Hmm. This is the process created, process ID 4340. Where is its parent? Parent user, parent's process ID 3140. 3140, so it means which one that 3140? It's a PowerShell that run it. That's the parent of it. So the 3140 is executed the update.exe and connected to the network. So basically is that command. Where is that command we got? Let's go to the detail. This one. That's a PowerShell, the parent process. No, this one is download and then execution came later. Now we can do also, we can trust TryHackMe and unzip this one. Extract all. And now we have, you can see it's a shortcut. If I go property, it's a shortcut, and you can just can see with a notepad, and you can see now the command, the same what we saw there. So it means if someone click on it, it download the update.exe from 10 14 9 15 and save it to that updater invoke request output and then start it. Oh, that's why I was confused. Who start the process is the same. The PowerShell started already here, so we got that. So let's look for it if it exists. Where is that user? This PC. Hey, Windows, sometimes I keep confusing me. The updater, roaming, Microsoft, Windows. Where he gone again? Where he said he save it? Roam under roaming straight. Update roaming. No, it's not in this machine. Okay, I thought they simulated in this machine. Let's see what's inside here. Let's see what happened in PowerShell red line. Oh, it's empty. I don't think it's machine. This machine is the one for testing. Let's see what TryHackMe was doing. Oh, they have C2 here. They're hiding stuff from us. RDP.avtx. Where they got this from? Oh, task 2. You have the zip folder test.zip. Where they got that from? Okay, okay, we're done with this. Let's not let's close it because TryHackMe on Windows they like to shut in machines. Persistence overview. Now we got the C2. Now next data steal infections usually have a very short lifespan. They breach the victim, collect the data, exfiltrate it, and exit all within minutes. However, for most other attack, maintaining access to the victim for days or even months after the initial access is vital. The tactic of maintaining reliable long-term access to the target that can survive reboots and password change is called persistence. So we have reboots and password change, a big and interesting topic that you will discover soon. Discover soon, so it means next room. Short-term initial access, user reboot the system and stop malware, system update fix the exploit vulnerability, IT change password and the breach RDP of the breach RDP user. So it means he's killed straight after initial access. Persistent long term, of course, when you have persistent via RDP, many Windows breaches happen because they exposes RDP with weak passwords. Many ROM do this. Of course, for example, now threat actor often deploy an additional persistent method. For example, create additional hidden vulnerability in the breaches service. Example, backdoor or web shell. Create a new user. So T1136. This is one known. Create a new user. Make it an administrator and use it for further LDP login. Let's focus on the second method now and see how the threat actor can manage user in Windows. The first option is to use a graphical utility by searching for computer management or launching. Yeah, basically because he has RDP, so he can use the graphical interface. And of course, a net user add this password, then later add it to the group administrator, for example. Detecting backdoor users, it's time now. If we for us is every user creation event logged security 472, so we look for 7204 new user. Of course doesn't mean every new user is alert. We need to know who, what, which, who created the account, can the person confirm the account creation, what the source IP, which other suspicious event can be seen in the creator session, so we know is really the attacker or just a normal administrator. And then after that they switch to privileged user. Next, new user by itself won't give an attacker much, as the default user permission don't allow remote RDP. Now the next one, to overcome this, the threat actor will add their backdoor account in one privileged group, and here we stuck with this security 4732. So we have 4720, we have 4732. The most common group is administrator and remote desktop users. Lastly, resetting password. In more advanced cases, the attacker may simply reset some old unused account. So you don't reset an existing user because the user will see is not able to log in and attacker detected. So they look for an old one. You can detect it with security event 4724. It means a password change. So security 4720, a user account was created. 4732, a member was added to security group, and 4724, attempt to reset password. This is what we're looking for. Of course, another one I think is 4725, which means failed login. That's also important. Now they give us security task number 3. So let's go to, what's this? You can see there. Let's go to practice. Now task 3, let's start security. Yes, I'm getting tired. Reading is sorry guys. Oh, the good things in this room, you don't have too much data. Remember, sometimes you find the logs like a million, 50,000 or something, and so basically here, if you follow the question, they already tell you so how many times. So there was a failed access to administrator, and after successful login, a backdoor was created and was added to the group. So we know the group is 4732, account 4720. We're not doing we're dealing with the reset, so we're only looking for a failed login. We can see it here because no, not you. Let's go this down. I forgot why is not showing the name. If you look now for the 4624, no, this is an account was successfully logged in. The 465, it said account failed to log in. So the event 4624 is an account was successfully logged in. This one is login type 5, and I forgot. Windows sometimes when I make videos. What is login 5? It's not a RDP. This is the system. So kind. It's no, this one. It's not what we're looking for. Here they cleared the log. So here you can see account fail login, account name administrator, account domain desktop 4K, source network address 10.14.97.15 is not that the attacker. I think it's the 10.14.97.15. 10.40, yeah, that's the same what we have before. So we have a failure here, failure. So we have 1, 2, 3, 4, 5, 6. So we can say we have 6. We can answer this question. We have 6 failure login. Now what happened after the 6? Now we can see the 64. That's it's a login. So we have an account was successfully logged in. An administrator. Did I give that IP? Yeah, that's the IP. So we know it's the attacker for this. What's that one? Yeah, Windows always like to have too many login things. Now let's see what happened after this Mr. Logged in. 24 still login. I forgot that 5 things. I think then we're not interested in 48. After his login, now we're looking for if he's creating something. What's the 48? Attempt that that Windows stuff. We're looking for more the event for creating. If it create a new user, we're looking for 4720. Let's see if we can find the 4720. Well, we have a 4720 there. A user account was created. Now, are we still? No, the source IP change. Not account name administrator. Yeah, new account support. So we know now that these guys created an account called support. Oops. Why TryHackMe? You said is wrong. We have a support there. Now the next one is what exactly did the attacker do? That's why it's better you know the number so you don't get confused. So what else we're looking for? We're looking for if he's doing any group. The group this is the group, the 4732. So if you don't worry about the rest, so you look for does he did anything. We can see 4732 there, city group, security group management. And what happened here? We have the support. This is the built-in before the privilege change. Subject. If you look for the 473 next one, a group. Now we built in administrators, so we can know what happened next in these things is it's adding administrator group here, administrators group. So we know part of the story. Now let's close so TryHackMe doesn't shut down the machine, doesn't take too much processes. Sorry. Malware persistence. Persistence via a backdoor user work well if you can remotely log in it via RDP. But if the attack started through phishing attack or USB infection, that's not an option. For these scenarios, threat actor need an actively running malware that maintain a connection with the C2 server even after system reboot. How could they achieve this? A classic, um, a classic persistent mechanism. Usually, when you always get rooms like that, is create a Windows service run after a startup. Usually they use this command sc create a name, whatever you want to do, and the path, and start auto, or create a scheduled task run after a startup, start create, for example, task name, uh, what suppose it do, and then on start runs it launch, and usually you can look it because you see the binary, the Windows schedule task binary, process creation sysmon 1, or for security for 698 for schedule task creation. Here also always sysmon always 1 for launch. This one was the service sc security for 697. Detecting services. Many critical Windows components like DNS client or security center are services. You can view service by launching service MSC. We have them here. What's this? This is the registry. Let's service.msc. Really? Oh, oh, services. I'm not in Windows. Sometimes Windows, when you don't work in Windows, make sure. What did I type here? Services.msc. What's there? MS. Oh, okay. I remember one of the rooms talk about this, how to detect which one is which one, because there's too many of them here. I forgot, like status running, startup type disable. Oh no, we need to look for the one manually. Where is the auto one? Automatic. Amazon Light.com event data protection crypto. I think is this one. I remember the room because I did this. So you know it's automatic. Let me open it. Let's see if is it him. Log in. What exactly this one do? You run Windows help nesses.exe. Enough to look legitimate or something. I'm not sure. Let's follow the room. No, bad service. Detect the launch of the SC, create a command via system ID 1, detect service creation via security event ID 4697 or system ID 7045, suspicious process with the parent, because this the parent usually do. So ID 4697, what is again 497 is the service creation, bad service process tree, usually the service, and then the svec hosts the windows, then launch the malware. Detecting tasks. Shadow tasks are another Windows feature heavily used by both OS and external app. You can manage tasks. Unlike service, shadow tasks are very easy to configure and hide, which is why the most common persistence method for threat actor like this ATP2841. Of course, it's about the process. You look for the process scheduled task. You can only filter in the name of the process. Process 1, detect, analyze scheduled task creation event, or you filter with events. So it's same things. We have a scheduled task. Where are you? Schedule task manager. I don't think the TryHackMe they put a fake one here. Amazon. Yeah, they are here. It's with them confusing. You can see the. I remember when I solved this room because you need to open them to see them because that's when Amazon sync, so you can think it's a good action, and then it run our the Tory malware. So the name is very sometimes most of the time is confusing because you don't suspect it. No, let's practice to see them. You have task 4, task 4, task 4, task 4. Let's go back. We already find it is dodgy character here, but let's see if we can see task 4 because I'm getting tired. So we have two security all time and then sysmon after reboot. Let's open both of them and let's see what we get. Let's put them next to each other so we can know what we're looking for. I hope TryHackMe doesn't shut down our machine. We have that. Let's open that the sysmon one. Put that. Sysmon usually is good. So we have what is a sysmon after reboot. So after reboot, let's see what happened after reboot. And then we have all time. So they give us all time. So what exactly we're looking for services and for schedule tasks. So the story said which Windows server was created and which schedule task, and then when you find the Tory malware. Now we know which one we're looking for because let's look for the service. Detect the launch of the service sysmon ID 1 or detect the service creation via security 4697. So let's say 497 because I said you can do the filter because we don't have 2 months log, we can just scroll them. Why is that for what? I always forget them. 4697 for the service. 4697, we have it here already. This is our friend Google, that's not you. 4697 update SV. This is Google too. This is security all time. 4697. Oh, now we have something. Data protection service. So what a service was installed in the system. Where is that command? Okay, they just said installed. This is the edge story, but this one it tell you there's a service was installed. I'm looking for the command. 7045. Really? It tell you installed here. But where is the command that installed it? Who's this? This is Edge. Don't tell me I'm confused now. This our friend Edge. Oh, hold on. Google. So what? 4697. Security system extension. It just said to you data protection service. A service was installed, but it doesn't show me the command of it. Let's see our friend there. Let's trust. What's the time of these things? This is after reboot. This was 7972, but this one is after reboot, so each is going to 4. So we are not in the same basket. There is a process 1. Who is the process 1? This is Windows. That's not a problem. Well, now we have a registry. Now we have a registry problematic. 13th. Who's changing? It's a Microsoft. This is Microsoft stuff, so we're not worried about it. The process, the service state. No, not yet. Guys, we're not. We need to find the answer. We're not guessing it. Process. I'm looking for the process who create. I don't think we'll find it because the date is 4. This is after reboot. Why they give us this one if he's not interested? Oh, that's the service. Okay, let's go backward. What that service is doing. It's Alsace. Then we have Alsace. That's not our problem. Oh, that's his service SV host. This is the shuttle service, huh? I know. Uh, yeah, the service will launch through SV host. Uh, SV host, but not this one. The one that do the shuttle is. No, we'll find it now. Not you. Not you. What this is a create rule process. Not you. Tempt. I'm not sure if I'm looking the correct stuff. Net service schedule is launching the schedule. Let's see what happened after that. Then cache. Not you. Not 6. I'm looking for process 1. File created. A Windows logs a nightmare. I'm looking for something interesting, but like we are jumping in. Not you. User manager as pool. Hold on. Oh, now we have something. Now we got it. Well, basically, if you look in the process name, the process ID 2176, this is the Troy things. The parent process is 1540, which is mean that service that we did before. What? 1540 parent process 1540 parent image. Yeah, you can see now when that schedule launched by the remember when they said this, um, when Windows run that service things that for schedule, you can see now the parent command we were looking for that svc host my SK net service my schedule is starting the schedule. this is the parent image automatically launched our Troy malware, which is in the program file common file Troy. So we got the schedule. What we've been doing here? Oh, the service we found, a service was created. And remember we talked about it when we said it's a data protection. That's the one we got it last time. So we know the name is data protection. Where is the stop pause logo log system account not recovery? Uh, yeah, path to executable is windows helpnesses.exe. So let's first, before we get confused now, which schedule task was created to persist the Tori malware? Oh, the schedule task. Did we saw it? Okay. We find it here is Amazon Sync, but we didn't see it in the log. In the log, the schedule we should go for. Uh, 4698 is the schedule. Before we looking for 67 for this the service. So the schedule is 4698. Let's see, 4698. Where are you? 4698. This is the window. Chrome 4698. Chromie. No, hold on. 4698. Task name. 4698. Microsoft updated browser. That's not what we're looking for. Look how it look funny, this service. That's the Tori, the Tori 4698. What's the name of this thing? Policy ignore. Task name. You can see the name there. That's the dodgy character of the name. So we got there, and basically, because of the path of the executable, the Tori one. So the same what we found it here. Oh, that's the name. Amazon Sync action. It start the program common file toy. Let's get that. I'm getting confused for a moment. Then what the Tori malware? Okay, let's trust TryHackMe and go to this file, program file, common file Tori. So we go to the C folder, program file. What is it? Common file and Tori. Let's start it. Oh, not so fast. What was my parent command line? Ooh, hold on. Where we saw it in Sysmon, that the Tori things. That's the Tori. Uh, it's asking for what? Yeah, it's the parent command. It should be this one. It is a service. So let's see if we are correct. Incorrect. He said to me, I'm incorrect. Seriously? Which one we opening? Task 4. No, this common file. What is my parent command line? Oh, the command line. Let's see what the command line is. Your command line, the one that launched it, not the image, the command line. My parent command line. So no, not seriously. Did they took it to the spaces or something? Did I I did solve it yesterday. How come it was simple question? Why I'm not getting it right now? Oh, the full command. Maybe he's asking for the full command. Control C. Let's give him the full command. Oh, the full command. Yeah, you want the full command. Thank you very much. Now we can copy that before it crashed. Let's put it there. For a moment I said what? So we're done with this. Let's close them so computer doesn't crash. Close this one. Because Windows machine, TryHackMe, there's a memory or something. If you keep them open, let's close this one. What else we have open? The service that we got, data protection. Sorry guys. Run keys and startups. Here we're talking about usually auto start service and share tasks are typically run on system boot and require administrative privilege to configure. However, what if a program has to run only when a specific user log in? For such cases, Windows provide a few per user persistence methods that are actively used by both legitimate tools and malware. The classic one is that startup folder. Uh, yeah, Windows Start menu, program startup malware.exe, new startup item system 11, 11. File created process. Yeah, add malware in Ranky. This is when you go to the registry, you look for this one. Software Microsoft Windows current version is very famous. This one. Windows 13.13 is always remember it is the key. Now, detection startup. The startup folder was meant to be an easy way for an experienced user to configure program to run on login. You simply open startup folder, move on, and they tell us see user update roaming. Let's see where is it. Um, Local C user administrator update local what? Don't joke with me. Update roaming, not local. Roaming Microsoft Windows. Roaming Microsoft Windows program. What are you? Startup menu. Program startup. Oh, we have odin.cmd here. It's hiding there. Okay. For all users, go see program data Microsoft Windows start menu program startup. That's different story. We're not doing that one now. The startup folder is not a common choice for legitimate programs, so usually the folder is empty. Still, threat actor often put their malware there. Luma is still an example, and you can detect it by monitoring file creation event. Sysmon 11, yeah, that 11. Inside the start folder, also note that the program launched via startup will have an example explorer parent. So usually, well, that's another sign for you for detection. So it may be hard to differentiate them from legitimate user activity or attack you learned in Windows detection, threat detection 1. So we have sysmon ID 11, user for example, process ID image, image target file name, you can say malware. So you start PDF, target there, startup process explorer, startup the malware that was from attachment, and then you have that. Now let's see what we are doing here. Detecting the keys is just go there. So we basically you usually like it. You can just copy this if you get. That's why I like to do this. We get the registry. We can just go to there. Control A, Control V, and go straight to the run key. And we can, yeah, we can see it's C user public kitten dot, dot. Yeah, many exams and things, you always go here to this run key and run once. The next to it is run once, doesn't have, you go to run. So you can see kitten.exe, it's running from user public folder. So we have this here, and we have this Odin, the kitten Odin, and we have the kitten one. So let's follow the story. We already opened this and we saw it there. This is okay. Let's practice. We give us task 5 before the machine collapse. So we have this, and let's go to task 5. What we have in task 5? We have two system after and before. So let's start before. Let's put it left, and after let's put it. What's going on here? This one is after this. Oh no, don't go big. I don't need this window, so we don't have too much data, so we're not filtering. So we have this, and then we have this one. So we have before reboot. Let's see what happened before rebooting this machine. So assuming this process creation. Well, who's created this process? No, let's do that. I can't see too much here. This is a command. Someone run a command in desktop. Okay, what happened running this command? This file creation. Oh, now we have the Odin. So this startup process ID 3192, the command and the target. So it auto starts something here. So we know this Udun. It's an updater. I mean, we found it already. And then this is our friend Chrome. No, I think this is different stories of Chrome. This DNS query. Who's calling query? Chrome. There's always Chrome doing that. No, this one is part of the normal Windows stuff. I think we're not there. Once live Azure Edge.net. That's not. No, the interesting one is the registry, the 13.1. No, not this one. This was the normal Windows one. There's another. Oh no, something is running here. The kitten one. You see the kitten. Uh, it it was added to registry. Process was created, and we can see later on the run. The key is in this kitten things. You can see the key basket, and we can know where is the basket key. You can see the name of the key is basket, so we already got it there. So we know registry basket, and that's it. So what exactly we got here? We got the registry for that. Let's follow the question. Sorry guys. What is the parent process image of Odin? The parent process image for malware Odin. Here it was created, it wasn't run, but this where we found Odin again. This is the kitten, the Odin, we found it in the process. Where did we saw Odin? No, this is not. I forgot where I saw the Odin one. No, the registry, it was for kitten, not for Odin. Did we find Odin here, or I'm just confusing myself? This is no, this is a command that we talk about it. Huh. It was created or something here. Let's see what happened. This is what before reboot. Let's see what happened after the system was rebooted. Uh, after system reboot, this is not our interested. The normal Windows stuff, task scheduler. You can see the task scheduler is running as before. Not you. The registry tricket start, not you. That's edge stuff. Now we have some registry. I think we more because the registry was created already in this side. So here we're looking more in the processes. The process starting process for the malware. The registry is more normal than Windows stuff. This is the Google update. We're not interested. Where is that malware stuff? Uh-oh. Now that's update Chrome. Our friend Chrome smart screen. Usually, yeah, you can. Now the kitty. Now the starting of the kitty things, because remember the kitty is inside the auto run. So now it will run. Let's see who will run it. Now it run with minus the command line. What's the question? What? The parent image, not the command. The parent image. You can see the parent image of it. Explorer. Let's not copy spaces. Let's do that. So we got the kitty. So the kitty runs. So we know. What is the last line that Odin malware outputs? So it run. This is the process. Start menu Odin. Oh, that I'm getting really confused. This is the Odin and the Odin, not the kitten. What's this one? Odin. This Odin is running. Oh, now it's running. You can see it running command. Let's before we jump. This is 5352 process ID 5352. Who are this? You can see the parent is 4000. So this is part of the Odin because 5 is the parent. So this is the child of Odin. And you can see command line PowerShell command write output doing bad stuff for I equals 0 I wherever you're doing loop things. Start milestone for each start sleep millisecond and then write output done doing bad stuff. So basically that's the end of the code, and that's why if you want to cheat, if you want to you can't cheat, because if you run it, it say print fast 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 and it's close, so you need to be fast to see it. Where is it? Let's guess it. No, it doesn't run. So they play with us, TryHackMe, for this one. So you can record it and see what was printing, and then type the answer. Or you can come here and then copy it. I can't see. I'm getting. Let's copy half of it and add the exclamation mark at the end. Let me add now manually the exclamation mark. What's the flag when you finding the running kitten malware? The kitten malware, we already found it many places, and we know where the kitten is in user public. So let's go to user public. The Odin is there. This C local C users in the public. When we find the kitten malware, they said, oh no. First, what? How is my run key named? We already see. You can see it here is basket. So it's called basket, but we saw it somewhere. The kitten one. It's in the registry. A basket. You can see it's a basket. Not you. Not you. No, that's directly that one. So the basket one. No, but I thought it should be more fancier command. Where is There's no other registry here. Yeah, that's the basket one. So if I go now, answer is basket. No, he gave me the. We're lucky the machine is still working, and I'm getting seriously tired. Uh, how about this one? We finish. Impact and threat detection recap. Need for persistence. In the previous task, you have learned how threat actor can remain active on the system, but why would they need it? Why not just steal the data and exit the system before detection? They can pick up a reason, for example, add a host to botnet and use it for further attack, like how the Kraken botnet combined crypto miner data stealer and C2 capabilities, spying the victim as a part of a state-sponsored campaign, like how Volt Typhoon stayed undetected in US electricity grid for nearly a year, use the victim as an entry point to the network, breaching which could take months, like in case where the threat actor spent 29 days breaching full network, like your hack box or something in network Active Directory. Active Directory and ransomware. Let's start, for example, the most dangerous one is of course ransomware. Like if we give us an example of ransomware that happened at McLaren Hospital, affecting 743,000 patients. Just imagine, like for example, you can see a screenshot of this. Your data is stolen and encrypted. If you don't pay the ransom, the data will be published in our Tor darknet site. The sooner you pay the ransomware, and they give you the browser link and a normal browser, things like that. Threat detection recap. This is basically for the three room that we did. Active Directory and ransomware. I am complex topics, and but all complex attacks start from a single breach in the Windows threat detection rooms. You explored how breaches began, how the attackers steal data, and how they remain undetected for years. You are now ready to use acquired knowledge to detect and stop the attack before ransomware caused this disastrous impact. Of course, prefer you detect the attack right after initial access. They give us, for example, here a quick recap of what we learned so far, highlighted in yellow. For example, initial access, expert application, remote services, phishing, execution, command and scripting interpreter, schedule, task jobs, persistence. There's a big skin if you want to read about it. What's the biggest threat for corporate? I'm tired and I'm not. Just copy and paste. It's a ransomware. And then let's type this one, initial access. Basically, it's better to stop initial access before they go further and notice. In this, you may explore command and control phishing. Is there another room? I hope you enjoyed the Windows threat detection journey. So there is no other room. Okay, let's finish it and we can say, hey, this one took, I thought it would be quick. I didn't want to go too fast in this room because I thought maybe we can explore things slowly. Okay, I hope you guys you enjoy it. If you have a question, let me know in the comment. Please like, help the channel grow. Subscribe if you're not. Thank you very much and have a good day.